Hey guys, welcome back. Today we're going to spend a little time talking about arcs and chords. Now in the last section, remember we talked about arc lengths and arcs and some of those things about this. We're just going to take this a little bit further and relate it to chords, which we talked about in the first section. Okay, so we've got a theorem here that says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So basically here's what this is saying. You see this picture here with a circle and it's got two chords. Okay, remember the chords are the things that cut through the circle that have the endpoints on the actual circle. Okay, if AB is congruent to RS, so basically if those things are congruent, then the arc AB, which is this one here, is congruent to the arc RS. Okay, so those that theorem there tells us a pretty special relationship. We're going to use that quite a bit often, and it helps us prove a few other things. But that's one thing I want you guys to just kind of keep in mind. So how this works is something like this. So it says find the length of AB. Now they're going to have to tell you specifically that one or the other is congruent. And as you see here, the arc AB and the arc RS are congruent. So what that means is these two chords are then also congruent. So 3x minus 7 would be equal to 2x plus 1, and I could set that up and write it as such, and then solve. So I subtract 2x, add 7, subtract 2x, add 7. Solving this out, I end up with x equaling 8, and there's the value of x. Now, notice that's not what it asked me. It asked me for the length of AB. So I now take this and substitute it in. So 2 times 8 plus 1 equals 17. That's the actual length of the chord that I want, and there you go. Okay, so from there, we keep moving. Here's a couple more theorems. It says if the diameter of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, and you can see in this picture here, I've got a diameter and a chord. Now notice it is perpendicular because of the right angle. Okay, so there's my right angle. If those things are true, then that thing bisects the chord, means cuts it in half, and you can see with my congruency markers there. And it also bisects the arc, which is out here on the outside. Those two things are also congruent. Okay, so that's a nice thing to know. Now the other theorem here says the perpendicular bisector of a chord is the diameter. So what it's saying is if these two things, if these two things are congruent here and here, and here, okay, then that thing is a right angle, and the line that makes that happen has to be the diameter. Okay, so that's kind of what this is talking about. It's just more or less going the other way. So here's some questions we can use these theorems for. So it says the measure of PQR is 98. So think we're going from here to here is 98. Okay, find the measure of arc QR. Well, because this thing right here is a right angle, what does it do? Well, it cuts this in half, but it also cuts this in half. So since the arc of 98 gets cut in half, QR would be 98 divided by 2, or 49. So the arc measure there is 49. All right. Next question says if TR is 6, so now we're looking at this, find PR. Well, same idea. Okay, this thing has a right angle. It's a perpendicular bisector. Means it cuts it in half. So that's 6.
Merrill, please come to the office if you're in the building. Merrill, please come to the office. Thank you.
Sorry, busy day here. So TR is 6, which means that PT is 6, which tells you then that PR is going to be 12. And there you go. All right, final one. And this one's a little bit trickier to look at. It says if the radius SQ is 12 and the chord PR is 18, find ST. So the ST is saying that there is our center. We want to know how big is that. Okay, and that is our X. We've got to look about this a couple different ways. SQ is the radius. Okay, now a radius can be found anywhere. So let's say, what if I made SQ turn into SR? Okay, because that's also a radius. And so that radius is 12. Now we also know that PR, that chord, is 18. Now since this is a perpendicular bisector, it cuts it in half. So that side right there is 9. Now, if you notice what we have a triangle with a right angle there. We've got a right triangle. So you've got this triangle of 12, 9, x. There's our right angle, and we can use Pythagorean's theorem. So Pythagorean's theorem said x squared plus 9 squared equals 12 squared. So x squared plus 81 equals 144, which means we now subtract 81 from 144, and you end up with 63. You then take the square root of both of those. Now 63 is a number that has a perfect square, so you can leave it as square root of 63. You could put that in your calculator and do the square root of 63, which is 7.9, or even better, find a perfect square that goes into 63, and you're looking at 7 times 9, which would simplify down to 3 square roots of 7, and there you go. All right, so that's the distance there. Now you have to just kind of understand that you're taking, because QS is a radius, you can create a radius anywhere, and it has the same measure. All right, final idea for this is another theorem. It says, in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So I've got this picture here, and in this picture, it shows two chords, and they have right angles, which, as we've seen in the past, is the shortest distance between 2 points, straight line, and they always meet at a right angle. Okay? It's another way of thinking about like an altitude. Now, because that's the case, these two things are congruent, which tells you then that the entire chord is also congruent. And that's what that's stating. Okay? So we go down and look at our final example. So here it says XL is equal to LY, which is 8. So those two things are congruent. And that's what we get from there. Okay? We also get FG is 3x minus 4. We get HJ is 7x minus 18. And based on that theorem up above, those two chords have to be congruent. So I've got 3x minus 4 equals 7x minus 18. And we solve. So subtract 3x, add 18. So cancels, that cancels. So I've got 14 equals 4x, divide by 4, and we get x equals 7 halves. Okay, once you reduce. Now, notice what it asks. It doesn't ask what x is, it asks what fx is. So we take this and we substitute it in. So you got 3 times 7 halves minus 4. Okay, well, when we multiply here, you go straight across, so that's 21 halves minus 4. We need a common denominator, so what over 2 is 4? And that would be 8. So subtract here, 21 minus 8 is 13 over 2. So the value of that FG is 13 halves. All right, on your own, pause the video, give that last problem a try. Okay, let's see how you guys did. So this one says that FG is equal to HJ is equal to 21. Okay, so those two are congruent, and that's all we get from there. Now XL is 5x. LY is 3x plus 4. We want to know what's x, and then what is LY. Well, because of this, that thing has to be congruent. So 5x is equal to 3x plus 4. We solve. So subtract 3x. You get 2x equals 4, which means after you divide, x is 2. All right, finally, find LY. We're going to take our 2 and substitute it in there. So LY is equal to 3 times 2 plus 4, which is 3 times 2 is 6, plus 4 is 10. And there you go. You've got a value of 10 for each of those values from the center to your chord. All right, hopefully that clears some things up, helps you out. If you have questions, please don't hesitate to contact me. That's what I'm here for. Okay, find a way to get in touch with me, and we'll work through some of these problems. All right, good luck. Talk to you soon.